Just to start the presentation, let me set the context I'm working on. I'm mostly interested in mobile devices and how to efficiently deliver services to mobile devices, but most important, how to deliver services by mobile devices. I have this peculiar tendency to treat a mobile like another component in our software architecture, that we actually can run software, some services on it, and get some feedback, some execution. And when we talk about mobile devices, context awareness comes close to these topics. But I have reactive streams in the subject of my presentation. So I'm pretty sure that most of you are familiar with the reactive streams concept, which is popular among this functional conferences. To my best knowledge, this reactive stream originated from the graphical UI systems that were used to describe how the user events propagate in the system. But contemporary understanding is that it's a way of describing asynchronous communication in the distributed system. So basically, at its core, we have a publisher and a subscriber, and the publisher produces data, and consumer or subscriber would like to efficiently and at its own pace consume the data. So there is some feedback loop that subscriber specifies the demand. So as it's highlighted, it's for governing exchange over asynchronous boundary. So then the subscriber is not forced to buffer data. And yeah, it's pretty natural when we design and build a distributed system. We have message queues, some nodes, some pieces of architecture. But when I started building software for mobile, so I came across, just also to describe the Reactive Stream API. So what it does consist of? We have a publisher, it's pretty natural. We have a subscriber, and we have a subscription. And we can see that this subscriber is pretty everything callback methods here, that subscribers notified after subscription is active, next element are delivered, then there's an error on the stream, or the stream is complete. And the important element is this request method on the subscription that is used by a subscriber to provide the feedback. But in the mobile world, let's imagine some imaginary service that will deliver you feed data. For example, you have an application that gives you hints where you could go while you traverse the city. What are the restaurants, pubs, places you could go. And here we have a server and our vintage mobile phone running Android 1.0 probably here. And this phone is requesting for a stream of data. It's specifying the demand and it's getting back data. But there's one little thing about this. This phone has a limited data plan. It cannot consume arbitrary amount of data because it will cost a user money actually. And the second thing, please give me more data, but I have very low battery here. And it's probably this data should be somehow adapted to the context of the reception. And the second thing, it's very hot outside. So actually mobile phone can give this hint that it's hot, that probably should prioritize on the list of the places to go and places you could have cold beer or ice creams. So that's the cases I came across. So actually what I'm wanting you to compare subscriber that is mobile to a non-mobile subscriber. Frankly speaking, one could say that, we should treat our software components uniformly, but there are some apparent differences between those two systems. And one is that for the mobile, non-mobile stuff, you can say that we have more or less stable power supply. And we have more or less stable network connectivity, and our resources are dedicated to the server running, server application running on the server. And we have more or less stable look what's the world outside. The server room, right? With nothing allowed to see. I put an asterisk everywhere because, things happen. But for the mobile, it's very apparent that we have limited source power that changes. Our network connectivity changes. Our resources are often more allocated to the front-running tasks, not to the back-end task. And if you would like to use mobile devices as a service execution unit, it can have some impact on that. And then mobile can actually give you some feedback on or context. Okay, what's the world outside? And just to set my point, I'm focusing on the system where the context awareness is an inherent complexity. So we are building an application where without the context, this application would not make sense, or we have very limited capabilities. So it's strictly for that. And one application I built in mind I started with this application, and the concept of this enhanced reactive stream came from it. I built a platform called social computing, and it's used to run some computational task on mobile devices. Our mobile devices have this very limited capabilities, like 8 cores, 4 gigahertz, 2 gigahertz processors, a lot of RAMs, right? So actually, what we have currently in a mobile phone is more or less what we have a couple of years ago in our like powerful great computing servers. And what I'm like guaranteeing my users that I will only execute the task when they are charging their phones and they are on Wi-Fi, because I think nobody would like to contribute their phone and it would drain battery and like consume the data plan. So I'm using the mobile device as a computational service, and in terms of the reactive stream, the running device forms like a long-running subscription for a task stream. And device probably would like to get pass information about in what state the device is, meaning why, for example, what is the battery level, what is the network, what is the memory consumption, and so on. And then publisher could kindly deliver the tasks if there are such tasks needed for that. And what we notice that in our reactive streams that are, as I highlighted at the beginning, are all about backpressure, so that subscriber can give backpressure. But this backpressure is quantitative. So we specified that I would like to process n more elements. But what I notice in the application I'm developing, the concepts I'm developing, I would like also to have qualitative backpressure. So not only how the amount, volume of data, but also the quality, the properties of data that should be delivered. So I came with a simple like extension. Okay, if we want to pass this context data, so let's pass context with the request. It's pretty simple, but it gives a lot of powerful option to the publisher actually to consume this data. It's up to very use case specific. Okay, what application we are developing, but in our case, probably publisher will like trim the data, trim the task to the size of that the mobile device can consume within a reasonable time. But if we add something to the API, we need to think about consequences of it. So is it sufficient to only have a context? If we have context about where stream, we are passing context, and then is it enough? And as I stated a few slides earlier, mobile components are like sort of different. They are very fragile by definition. So when you are building a software component, software from components that actually can, by design, go on and off, just can get out of signal, lose connectivity, somebody can restart them, and so on. So when a mobile device is subscribed to a stream, server delivers data at some point of time. It's strictly asynchronous communication. And there can be lag between, because server resources can be occupied and there may be not data at some point of time. But if this period of time gets long, at some point of time, this context information actually becomes misleading. So, okay, 5 minutes ago, I was connected to the battery plug, to the network plug, but now, who knows, right? So its context is is causing some sort of like mess here. So reactive streams are very explicit API. So there's when there's an error on the stream, there's explicit method to tell you there's an error. So nothing is hiding there, and everything, I think, with this concept should be handled explicitly by the user. So what I added to this API is also a method that will allow the programmer explicitly handle this information. So the subscriber can react to the expired context. So as a subscriber, I give my demand, I give my context, but if this context is not used over a period of time, the subscriber will be notified of that, and the subscriber will be able to react, just provide new context if it's still able to process the data more. And finally, the context has a defined validity period. So yeah, so how much the publisher can rely on this context? The question is, could I go different way? Why this approach? So one way, if we have application that can give us, we need various various level of quality of stream, right? And you could have actually our publisher, we could have various publisher for various requirements. And the mobile phone, mobile device, mobile application could select the streams on demand. And another thing is we could have have another channel for communicating this context information as a additional asynchronous communication band. But the one thing is, if you want to answer the question for that, think about actually what is the life cycle of the mobile application. Actually, do we have if we run a mobile application, and just to give you a hint, I'm implementing it on an Android system. I'm not sure if it's for iOS the same, but actually when we have an Android application, we don't have a regular OS process or a thread, but we have abstraction of activities there that can be passivated and activated by the runtime as needed. So actually, and what would be the right frequency to actually send these updates if it's we should select the stream or pass this context information? What should be the rate of the updates? And when the device should make this decision to actually update the context? And the final question is, which resources scales better, on a mobile side or a server side? So if we want to add additional responsibilities to the mobile device, is it actually what we want to do? Because it will consume our battery and mobile resources. So my basic design assumption is that I don't want this mobile application, mobile services be active. I want them to be as passive as possible. So they will only react to this subscriber methods. So the mobile component will not do anything on its own. It will specify a demand, and when this demand is satisfied, the context expired, the stream has ended, it will only take actions. And I think it's a very explicit model for communicated because it takes a lot of responsibility from the mobile client implementations here. And bear in mind that backend have very huge battery, right? Our servers, and they scale easier. And usually when we deploy such platform, we have more control as a system owners over backend servers than mobile phones running. Yeah, one could say I broke a standard. There's this Reactive Stream API. It's pretty nice concept. It's such a beautiful thing, and I added one method that sort of breaks this concept. Right? You may have a feeling that often with reactive streams you do composition operation like transform, filter, map, the scatter, gather operations. And the question is whether it's possible to do that here. Because this context smells like a state in our application. And for the thing I broke the standard, I don't think I'm breaking the standard because the concept is, frankly speaking, more general than reactive streams. If we leave this on the context expire method empty and have a context that is actually empty, we come back to a regular reactive stream API. So this way, I could, like the classic reactive stream API, use my concept. But the question is whether this concept, this API, would be useful with the same method. And frankly speaking, I'm not sure, and I don't have exact question for that, exact answer for that. I have some suggestions, right? And the most important things I want in the applications I'm building, that this context should be propagated across the network. So that's the most important part. This asynchronous boundary, and it's where the context is relevant. So we have a context-aware mobile application and publisher, and then should be a context propagated. For the subscription part, subscriber part, I know you like to read the code on the slides. It's very readable, right? But to let you explain, we can always narrow the context-aware subscription to the non-context-aware subscription. It's the publisher object that is on the boundary of this asynchronous communication can enrich the request with the compute operation, and the rest of the application can use the regular reactive stream stuff. And for the publisher API, frankly speaking, publisher API doesn't say anything about this transformative functional operation and so on. It's where the RxJava stream adds that. But probably you would like to have something similar. And my basic assumption is that the context should be propagated to the point that it's understandable. So there are some operations like map that could sort of ignore this concept. But this fan-in, fan-out operation that merges or splits the streams is something that probably should be enriched with some context merging and so. But my question is whether we actually will need this, because the publisher is abstraction. How this backend is producing the data. And to me, in this case, for the perspective of the mobile clients, it's like an implementation detail here. But it's probably something I will work on in the future. OK, just to summarize, context awareness is in this application implies inherent complexity. And what I try to modify is an accidental complexity. So I would like the mobile client developer or this mobile service developer to have a simple communication channel that will express the intent of the communication well. And I want mobile devices to stay passive, because if I want users to contribute to my platform, I would like to give them guarantees that I will not abuse their phones. And in our design, we anticipate actually that our components will be going on and off. And we shift a lot of responsibilities to the server, because it's where we have the most control. And like 3 other things I learned on my design just to share with you. OK, every abstraction will always leak, right? We will find the way that, OK, this reactive stream API doesn't match it. But it's not something we should always try to implement and refine new API. We really need to have a strong reason for that, because when we have an API compiled into some binary implementation library we can import in our project, it gives our implementation some sort of safety that we are adhering to a standard. So it's when you think of abstractions, try to form them into API and test them so that actually they satisfy your requirement. But it's not like you should implement API every day for yourself. And for Android OS processes model, it's very different what we could expect from the Linux server. I tried to implement this reactive stream concept library for communicating with Android phones. I did it using Google Cloud Messaging for those who are interested. But it's actually we cannot expect that this application is live all the time. So it needs to be hacked around a bit. And API refinement should be bottom up. So when you want to improve your API, you should probably start with use cases and how it can be used. Okay, thank you. So.